Distinguish between intramolecular and intermolecular forces. The question asks for the attractions between separate CCl4 molecules that hold them together in the solid state. These are intermolecular forces. In contrast, chemical bonds, such as covalent bonds, are intramolecular forces that hold the carbon and chlorine atoms together within a single molecule. Analyze the chemical bonds and symmetry within a single CCl4 molecule. Each carbon-chlorine, CCl, bond inside a carbon tetrachloride molecule is a polar covalent bond because of the difference in electronegativity between carbon and chlorine. However, the CCl4 molecule features 4 of these equivalent polar bonds symmetrically arranged in a tetrahedral geometry around the central carbon atom. Determine the overall molecular polarity. Because of this highly symmetric tetrahedral arrangement, the individual CCl bond dipoles point in opposite directions and cancel each other out completely. As a result, the CCl4 molecule is entirely nonpolar. Identify the type of intermolecular forces, IMFs, present. Because CCl4 molecules are nonpolar, they lack a permanent molecular dipole and cannot experience dipole-dipole attractions. Therefore, the only intermolecular forces capable of holding CCl4 molecules together are London dispersion forces. Relate London dispersion forces to temporary dipoles. London dispersion forces are weak intermolecular attractions that arise from the constant motion of electrons within a molecule's electron cloud. This motion leads to momentary, uneven distributions of charge, producing temporary dipoles. These temporary dipoles then induce matching temporary dipoles in adjacent molecules, creating the attractions that hold CCl4 together in the solid state. This identifies option C as the correct answer. The correct answer is option C, intermolecular attractions resulting from temporary dipoles.